morning, everybody. My name is Michael Samuel, the president of Nobel Systems. I'm here to share with you our work on a smart water asset management system, and specifically how we've applied this technology, strategy, and on-the-ground implementation to support the water utilities in Uzbekistan. So we were awarded this project, and it was focused on remote monitoring of water pressure. The team developed a GIS and installed 10 IoT-based remote pressure monitoring devices at Uzsuvtaminot, which is the national water utility of Uzbekistan. Following the successful project with ADB, Nobel Systems approached the US Trade and Development Agency to request a grant for a feasibility study aimed at enhancing this ADB project, specifically to support development of a digital twin pilot system. In February 2024, final project presentation was held at the residence of the US ambassador in Tashkent. It was attended by senior management from Uzsuvtaminot and the ADB. So let's take a look at the core components and groundwork that define the scope of this project. So our team created the GIS, which included digitizing of parcels from satellite imagery. We then loaded the data on a mobile device to collect field data by GIS staff. This process efficiently captured the required data to complete the GIS base. The team then developed a hydraulic model that accepted real-time data inputs, as well as having the capability to alert system operators should operating conditions deviate beyond preset values established during the modeling process. At the conclusion of this project, residents in GIS were surveyed, and 85% indicated that this project had a positive impact on both their quality of life and improvement in the sanitary conditions for their households. Let's look at the core benefits delivered through the project. First, in terms of the centralized asset and data management. So the GIS-based platform consolidated water and wastewater infrastructure data. This project aimed to modernize water infrastructure by integrating digital solutions such as real-time monitoring, GIS asset management, and leak detection. Second, under operational efficiency and mobility, we have a mobile component. It's called GeoView Mobile, which sits on tablets, could be either Android or iOS, and that improved field data collection through real-time updates. It has an offline functionality, so that when you don't have cellular signal, you still collect data, and it automatically transmits the data when they get back to cellular. And easy to use mobile tools, enhancing responsiveness and reducing delays in both routine maintenance and emergency response. After completion of the pilot project, the feedback from the local community confirmed that when water utility managers have real-time information about system performance, they can take proactive steps to reduce the frequency of system pressure loss. The third benefit is scalable, integrated digital infrastructure. The system can be scaled across the entire country, just using the exact same tools that are in GIS. And I feel the next, which is very important, is public engagement. We have installed a citizen engagement app, which we actively promote to the citizens within GIS, and that promotes transparency, fosters public trust by enabling residents to report service issues such as leaks, lack of water, or whatever the problems they face. So this slide outlines the end-to-end workflow. So first step is it starts with the citizen submitting a request, such as a leak or service issue, either through the mobile app. That then gets to a dispatcher at GIS office. He then forwards the work request to the appropriate supervisor or the network master, who reviews and approves the request. The network master assigns it to a plumber to take care of the situation. The network master verifies this has been resolved, and the system automatically notifies the citizen that the issue has been resolved. Especially if they've entered the request through mobile app, they get an alert back on their app saying that we've taken care of the system. And so completed requests are visible to all app users within their area, promoting transparency and accountability. So going back to the benefits of the project, it supports strategic planning, the availability of detailed spatial and attribute data, enables data-driven decision-making, supports infrastructure investment planning, and improves performance monitoring. Finally, local capacity building. Targeted training programs have equipped USD staff with essential digital and operational skills, strengthening institutional knowledge and reducing long-term reliance on external consultants like us. In the next few slides, we'll just walk through briefly about the most significant barriers we faced. One of the biggest challenges was data hosting restrictions. So according to Uzbekistan's law on personal data, all personal data must be physically stored within the country and registered with the Uzsuvtaminot. Continuing with technical challenges, we also faced issues around data availability and accuracy. Without existing paper-based maps or reliable reference materials, even experienced staff from other cities such as Churchill struggled to collect accurate data. Now let's move on to the second category. The key issue was the staff members, they used to handwrite all the customer complaints in large notebooks. The staff members who handwrite in books had no idea how to use a PC. If you look at that picture at the back, Saeed Afzal is training him to how to even type on a keyboard. Hit the F button, hit this is how you do. And now they're one of the biggest users of our application, and it's phenomenal how it's transformed. But if we forget basics, we can never achieve success in a digital project. Another was inconsistent training. This project was theoretically completed in 2024. We trained them, we went and trained them again, we went to train them again, nobody was using it. Finally, I asked Saeed Afzal to sit with them, prepare a training program, and regular structured training resumed in March 2025. A third challenge was absence of long-term ownership. The pilot was successfully implemented, but there was no clear mechanism in place for institutional ownership of the system. So what are our recommendations? To build and maintain a reliable GIS, USD should work closely with relevant regulatory agencies to gain access to existing digital and paper-based maps. So to ensure long-term success of the system, training and capacity building must be a sustained priority. We conduct regular in-person training sessions for USD staff to help retain their institutional knowledge and ensure continuity. As you can see in the slide here, we have these billboards out on the street in GSI asking them to download the app and to report issues. Looking ahead, we recommend long-term GIS maintenance be decentralized and managed at the regional level because they know the system. This approach allows each region to take ownership of its data, promotes faster response times, and ensures system evolves with local needs. So these outcomes really demonstrate how technology and strategic planning together can deliver measurable long-term value. And I'll end with that, and thank you for the opportunity to present our project.